Okay, today I am going to talk everything about circular motion. So, an object moving in a circular motion must have an unbalanced external force toward the center. This force is called the centripetal force. As we have now centripetal force, so there should be acceleration toward the center also. So this acceleration is called the centripetal acceleration. Actually, we have two equations for centripetal acceleration. Those are A equals B square over R and A equals R times omega square. Here omega is a angular velocity, V is a tangential velocity and R is a radius of circular path. Using Newton equation toward the center, we can build an equation for centripetal force. So I am going to use Newton equation now. F equals m times A. Here F equal n times V square over R. So this is the equation of centripetal force. Actually here F is not just one force. It is the net unbalanced force toward the center. In circular motion problem, what all you need to do is just apply this equation toward the center. So let's move at little advanced part. Every time when I am teaching this to my students, so they ask, sir, if we have an unbalanced force toward the center, then why this object is not moving toward the center? This is because they did not understand exactly what Newton law is. What exactly Newton said is, if we have an external unbalanced force, then there should be a linear momentum difference toward the direction of that external unbalanced force. But Newton never said that the object should move in direction of that unbalanced force. So let's take simple example. So actually F equal m times A, this is not a exactly Newton equation. So Newton equation is this: F equals difference of linear momentum over time. Here the direction of force is the same as the direction of the difference of linear momentum. So I am going to apply this to this simple example. In this example, initial velocity is u. So we can write initial linear momentum m times u. Here v is a final velocity, so we can write final linear momentum is m times v. So here f is equal m times v minus m times u over t. So this is exactly Newton equation. So now I am going to apply this to circular motion example. So I am going to find difference of linear momentum between point A and B. Firstly, I am going to find the linear momentum of point A. So PA is equal m times VA. We should consider direction because linear momentum is a vector. So I am applying now point B. PB is equal m times vb. Let's take difference now. pb minus pa, m times vb minus m times va. Actually here we can't subtract vectors, we can only addition. So I can write like this: m times vb plus inside brackets minus m times va. So let me find the direction of difference between these two linear momentum. Yeah, this is the direction of difference between these two linear momentum. So that means the external force should be in this direction. Actually, this is what exactly Newton said. So I hope you guys understand very well about circular motion. So thanks for being in this lecture. If you want to more videos like this, and subscribe us.